In this video, we're computing the electric force and the potential energy between two positive point charges. So first we're going to get the electric force between these charges, and that's just given by Coulomb's law. K Q1 Q2 over R squared, where K is the Coulomb's law constant, and that's 8.99 times 10 to the 9th Newton meters squared per Coulomb squared. And we'll see why those units are what they are in just a moment. Let's plug in our two charges. So the one on the left is 5 microcoulombs, and micro means 10 to the negative 6th. The one on the right is 3.1 microcoulombs. And our separation distance is 0.85 meters, and I need to square that. So let's take a look at the units real quick. Those strange units on K are just set up to make it so newtons pop out of this. The Coulomb squared cancels one factor of coulombs out of each charge. The meters squared in the denominator is going to cancel the meters squared in the numerator, and I'm left with newtons, so this is good. When I crunch the numbers on this, I get 0.193 newtons. In part B, I'm asked for the electric potential energy between the charges, and that's given by K Q1 Q2 over R. If I wanted to take a shortcut here, I could just multiply the previous expression by R, and I would get the right expression and the right numbers to come out. But let's look at it from scratch. Again, investigating the units a little bit, I see that one factor of meters cancels, two factors of coulombs cancel, and I'm left with Newton meters, and a Newton meter is a joule, so this is good. When I crunch the numbers, I get 0.164 joules of potential energy. And just as a concept review real quick, the force between the charges is repelling because they're like charges. And if I release these charges from rest, they would spring off, one to the left and one to the right. Well, when I see that sudden appearance of kinetic energy, I can say, well, that must be coming from a potential energy. So there's definitely potential energy stored when you bring two positive charges close to each other. If you find the physics content on Zach's Lab helpful, click on the Zach's Lab logo on the right to browse playlists and subscribe to the channel. I produce over 100 new videos per month, and subscribing is the easiest way to find new content. Thanks for watching.